Here's the truth: you can't be a strong data scientist or data analyst without understanding some basic statistics concept. Most of the visuals, most of the reports, or most of the model you run are actually built on statistics. Now, this video is going to be talking to you about some of the major statistics concepts you have to have an understanding, and it's going to set you apart from the everyday data analyst or data expert. First of all, welcome to my cyberspace. Now, let's get right into it. What are some of the major statistics that you need to learn as a data analyst or data expert? Let's move on. Statistics, first of all, is like the discipline that concerns with the collection, organization, analysis, interpretation, or presentation of data. Remember, this video is not for you to go in depth into learning statistics. It's just for you to understand the basics so that whenever you run a report or you are working on a data analysis project, you can understand some of the rationale or decision making to be able to do the right thing accurately. Also, you also need to grab all the nuances to be able to, or you need to be a mathematician for you to excel. So don't be afraid of that. What is something called measure of central tendency? When you get measure of central tendency, we are basically talking about mean, median, mode, and range. And median is mean is literally the average. And when they ask you what's the average between two set or more of numbers, that's the mean. And what's the median is the middle number. Most of the time we don't use median, and I'm going to show you a scenario whereby it will be better to use median instead of using mean. Mode is the most occurrent, and range is the difference between the highest and the lowest value. You begin to wonder, why would I care about this simple concept? You would see that this understanding is going to set you apart from just the everyday data analyst or the expert in itself. Let me give you a perfect example of a mean. In case you probably know what a mean is, you can skip, but it's best to refresh your memory. So you have few numbers, 2, 3, 7, 3, 2, 1, 2, and when you add the numbers together and you divide them by the count, you get the mean, and that's what we do most of the time as data experts. You're looking for the average. The median is you arranging them in either ascending or descending order, then you get like the middle number. While the mode is you look at the number that occurs the most, and the range is the highest value minus lowest value. Yes, this is getting easy peasy. Let's move on to the next point. So we have a case study right here. Imagine you're tracking your weekly expenses. In every week you spend $100, and at some point you spend $700 in that particular week. You remember that week that was either Halloween or it was a special Thanksgiving and you wanted to get a lot of stuff. You see how your expenses increased high. Now 3 weeks prior you were spending $100 as your expenses. Then somebody asks you, what is your average expenses? When you do like add up your average expense with that, you do have 100, 700, and your mean is going to be $250. But when you do the median, which is the middle value, which is going to be $100. So if you think about it practically, what sounds like a true representation of what you spend every week is not the mean, is actually the median. So you start to see these nuances that when you are running your reports, you need to know when it's best to run mean or when it's best to run median. A lot of times when you have a number that's probably not evenly distributed, or you have numbers that are outliers, it's best to run median for that. Things like income, you want to run a median. Also, there's something that for you to know if your data is evenly distributed, when you run your mean, your median, and your mode, the numbers should look very similar. If they are way apart, it means that your data is either skewed to the right or skewed to the left. So what this is saying is that there's an outlier here, meaning the outlier here is 700. This is way higher. And let's say we have a number here called $5, meaning that weekend that your parents or somebody gave you all the grocery shopping that you needed to do and you didn't need to go to the store, or for some reason there was a pandemic. We don't want a pandemic again, and you didn't get anything. So those are outliers. You can visually see what an outlier is, or you could use a calculation for that. This video I'm not going to be talking about how to calculate outliers, but you just need to know the statistics concept and know when to really apply them. So, and that's something that I just wanted to mention in this case study. Another statistical measure is called standard deviation. This is kind of show like the distribution between the data. So the higher the standard deviation, it shows that your data is not evenly distributed. You can look at these numbers. Both of them do have like the same mean. If you add them up together, you could pause the video, calculate them, you're going to see they do have the same mean, but this data do not have the same distribution. You see this number is going on an increment of 10, but this is going from 40, 95, and 5. So you might have a mean, but your data is not equally distributed. So when you're doing your modeling or whatever it is, and there's a little bit of noise, this is what is actually happening behind the scene. So there's something called degree of freedom. Degree of freedom is just like n-1. So if you have a larger sample size, you have a higher degree of freedom. We probably want to have a higher degree of freedom. Normally distributed is a data that it's like I think it's almost similar to the other concepts. We are almost getting to the end. The other concept we have here is standard error. This indicates how different the population mean is likely to the sample mean. Think of this as you actually gave everybody like $100, or you are selecting people of different age group, and the actual age of most of the people of the mid age of everybody is like maybe 35. And for some reason, when you were selecting the sample of a population, maybe you wanted to select 20 people. You then selected 20 people, but the most of the 20 people you selected were young folks. So when you found the mean age, their mean age was 15 compared to 35. So what is the standard error? There is a difference between the sample population mean and the sample mean and the population itself mean. So population here is not talking about population as in just demographics. Population is the overarching or the total count of whatever you are mentioning. So population can mean we have 100 companies, that's the population, and you sampled 5 companies, that's the sample. So hopefully you get that. So confidence interval is a range when you plus or minus the standard error from the sample mean. It just shows you that, oh, I am confident. It depends on the smaller the meaning that we are confident that population results will fall within this range. So most of the time when we are running something like a sample, we might not have like an exact number of what it is, but we can say, okay, we have this confidence level, either 95% confidence level, that our results should be in this range, regardless if you test the general population or you just select a random sample again. Other things you would get to hear is times like statistically significant, meaning that we are more than 95% confident that the result is accurate. In some field, like biomedical field, is most likely they use 99% accurate. So most of the drugs that you see out there, they want to have 99% at least confidence or accuracy level. The largest number in the distribution, that's the maximum. It sounds easy peasy. Minimum is the lowest number in the distribution. Probability, the likelihood of an event occurring, and that usually goes from 0 to 1. So that's either 0.5, 1/2, whatever it is. So it's literally from 0 to 1. It cannot, probability cannot be more than 1. If you are saying more than 1, you're probably saying something else. Other statistical measures, you have odds ratio. It's just trying to look at, we used to quantify the strength of the association between two events. So for example, you say old people at higher odds of experiencing stroke compared to young people. So you could, this is like some technical terms. You can familiarize yourself with this. This is going to help you as you have conversation more with people about data analysis concepts. Percentile, this is used to compare to others within the distribution used in terms of percentage. So you can see I'm the 90th percentile in my class in terms of grade, meaning you're one of the top gurus and very intelligent. Quartile is also like percentile, but it's more of like 4 groups. And that's all. In case this video was a value for time, do want to subscribe, like, and follow, and check out my other videos. Ciao, bye.